Hey guys, this is Mr. Pites, and this is Waves. So we're moving on from energy and we're getting into waves. And what we'll find is that the two are actually linked pretty tightly. So that's why we're including this in our energy unit. So waves. All right, so first definition you guys need is what is a wave? So a wave, everyone, is a repeating disturbance that transfers energy from one place to another. Keyword here you can see in bold here is energy, that waves transfer energy. So make sure this goes in your notes. So two pictures of waves here. You can see this purple line here represents a wave that you guys probably have seen before, where it goes up and it goes back down and up and back down. This is carrying energy from left to right. The picture below also shows a wave. You can see the concentrated dots here and here, 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 and here. And then in between, you can see they're not very concentrated. Here, 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 and here. This also represents a wave that is transferring energy. So, keyword is that waves transfer energy. They do not transfer matter. They just transfer energy. And I'll show you guys a video here. Okay, so waves only transfer energy. If we watch this video, you'll see exactly what I mean. So we got a nice rubber ducky here floating on the water, and as the waves are moving, they're transferring energy. You can see that the duck is not moving with the waves. The waves are not making the duck move. Okay, they are simply making the duck go up and down. The energy is transferring through the waves, but not the duck itself. You can see here, the duck is pretty much just staying in the same exact place. So waves transfer energy. They do not transfer matter. Okay. So first type of wave that we need to know is a transverse wave. So a transverse wave, everybody, definition says, is a wave where the matter, right, the stuff, the little dots here, they move up and down at a right angle to the direction of the wave. Sometimes we'll say perpendicular. So if you look at this, the wave is moving from left to right. We can see that the energy is being moved from left to right. But if you look at one of these dots, like this one right here, you can see that it's just moving up and down. So in your notes, it asks for a definition and it asks for a picture. So for the picture, you guys can draw something that resembles this. Okay? And again, energy is moving left to right. But the matter, the particles that are transferring the energy, they're moving up and down. You can see they move up and down just as you see these particles right here. So energy moves left to right, particles move up and down perpendicular to each other. Okay, so an example, a perfect example of a transverse wave would be on the ocean. If you guys have ever seen a buoy, as the wave passes by, wave moves in this direction. The buoy never gets closer to the shore. The buoy just goes up and goes down and up and down. So perpendicular, as the wave moves left to right, the matter, the stuff that moves the wave, goes up and down perpendicular. And I'll show you guys another example. Here is the gizmo you guys are going to be doing today. So if you take a look here, we're going to create some transverse waves. So as the person makes the slinky go up and down and up and down, again, wave is traveling from left to right. But if you look at an individual slinky here, part of the slinky, it's just moving up and down. And take a look here with the lights off. This green dot represents the slinky moving up and down as the wave moves left to right. Okay, next wave is called a compressional wave, or what we call sometimes a longitudinal wave. So longitudinal wave or compressional wave, is one where the matter in the wave moves back and forth parallel to the direction of the wave. So moves in the same direction. So in this one, you can see that the energy is moving left to right, but if you look at one of these individual dots here, they are moving simply to the left and to the right, parallel to the direction of the wave. So if you guys were going to draw something here, you guys could draw something kind of like a slinky. This is a terrible one, but you guys will get the idea. So as you sort of pull back on a slinky and you let it go, right, the energy moves from left to right, and the individual slinky parts move back and forth in the same direction, just like you see these individual dots moving back and forth. So make sure this gets in your notes and this picture. Okay, so next part, we're going to identify parts of a wave. And this is in your notes as well. You guys will have to take definitions, and you'll have to label the wave that you guys have in your notes. So first thing we have is the amplitude. Amplitude is the distance from the horizontal axis to the crest or the peak. So here's your example. This would be our horizontal axis, sometimes called the rest point. The amplitude is the distance from this horizontal axis up to the crest. Or you could also say it's from the rest point here down to the trough, same distance here. So this should go in your notes. Next one is wavelength. Wavelength is the length of one wave. Okay, it is the distance from peak to peak. So from this peak to the next adjacent peak, or you could also say from trough to trough. So that's a wavelength. A crest is the top of a wave. Okay, makes sense. If a wave crests out to the top, and the trough is the bottom of the wave. Trough is down here at the bottom. So what I need you guys to do is to take these notes, and I need you to label your wave just as you see this one. Okay, here's a quick check-in for you. What is the wavelength and what is the amplitude? Taking your notes that you guys just took, what would you say the wavelength is and the amplitude? So the wavelength here, again, if we go from crest to crest, here to here, pretty simple, 0 to 2, we would say the wavelength is 2. Amplitude, if you guys remember, is from the horizontal axis up to the crest. So here's 0, right, because we're looking at this number, 0 up to the very top, which is right here. This is 3, 0 to 3. And as I said, it can also be the horizontal axis here down to the trough. And you should get the same thing, right? Here's 0. We go down to -3 again. Amplitude is 3. Wavelength is 2. Okay, next vocab word is deals with wave characteristics. The vocab word is frequency. The word frequency means the number of complete waves per second, and we measure it in a unit called Hertz, H-E-R-T-Z, named after a scientist. Hertz. So frequency, everyone, is basically how often or how frequent do the waves occur. So in this scenario, it asks what is the frequency. Again, if you look at the definition, number of complete waves per second. So how many complete waves? If I start right here, one complete wave, you go with me, we start here. We're going to go up, and then down, and then back up. There's one complete wave, right? Because we have gotten back to the original starting point, right? Here to here is one wave. Then we're going to go up, down, and up again, which gives us 2 full waves. So the answer here, number of complete waves per second, would be 2. And we could use the label HZ, which stands for Hertz. Okay, next one is period. The period of a wave is the time taken for one complete wavelength. So this is like the opposite of frequency. Not how many waves per second, but how many seconds it takes for a complete wavelength. So if we look at this, how long does it take for one complete wave? Again, start here, you go up to the top, back down to the bottom, back up to the horizontal axis. How long did that take? Look here, time in seconds. 1, 2, 3, 4 seconds. So the period for this wave would be 4 seconds. How long does it take for one complete wavelength? This needs to go in your notes. Okay, this is sort of on your own. So some wave characteristics. The questions I have for you: what is the frequency of each wave? So if you're not sure, go back. What is the definition of frequency? We did one as an example. What is the frequency of each wave? And I also want you to tell me what is the period of each wave. Again, if you don't remember, go back. What does period mean? And calculate the period of each and answer them. Okay, one last thing I got for you guys is wave characteristics. So wavelength and frequency are linked. So the way they're linked is that they are inversely related. So this will go in your notes as well. So inversely means that as one goes up, the other one goes down. So when one gets bigger, the other one gets smaller. That's what inversely means. So for example, as wavelength gets bigger, right, as the waves get taller and longer, frequency decreases, right? So the example I have for you here, if this represents here to here, say this represents 1 second. This first wave, we would say, the wavelength is pretty big, right? There's only 2 waves in here, right? We go 1 wave, 2 waves per second, and the wavelength is pretty long. Vice versa, as the wavelength gets smaller, so as the waves get tighter, frequency will increase. Remember, frequency is how frequent are the waves. So if we look at the bottom one, short wavelengths equal a higher frequency. So for example, look at this. From here to here, our wavelength has gotten much shorter, but look at our frequency. Now instead of having 2 waves per second, we now have about 1, 2, 3, 4, 5, 6. We have about 7 waves per second. So as the wavelength shrinks, frequency goes up. Vice versa, as wavelength gets bigger, frequency goes down. Okay, on to the next part of our lesson. What you guys are going to do is you're going to go onto Google Classroom and open up our Waves Gizmo link. And follow the directions on the back of your sheet to complete the Gizmo simulation. When you're done with that, you're going to tape that into your notebook on page 65, and you're going to grab a worksheet from the front and begin working. This is what you will turn in for the day. Again, go back, rewatch the video, make sure all your notes are taken, make sure you have good pictures. This will be your notes for waves. I'm not going to lecture in front of the class. This will be your notes. So make sure you guys do a good job. All right.